Chapter 2, Lesson 5, Solving Equations Involving Absolute Value. As a reminder, what is absolute value? It is the distance from 0, and it is always positive. So when I look at the absolute value, I'm just looking at like how many spaces. Well, there can't be a negative amount of spaces. So if the absolute value of x is 4, then x equals 4. But remember that there's something else that could go in there. X could also equal negative 4 because the absolute value of 4 is 4, but the absolute value of negative 4 is also 4. So in absolute value, there's always two answers. Unless we need the absolute value to be negative. In that case, there is no solution, because the absolute value of any number in here is never going to be a negative. And we want to solve an absolute value equation. There's a couple things that we have to do. The first thing that we're going to do is to isolate the absolute value symbols. So if there's anything else on the outside of it, if it's being multiplied by something or there's something being added to those absolute value symbols, get it on the other side. So isolate the absolute value symbols. So your equation should look like something blah, 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 in the absolute value symbols equals something else over here. There shouldn't be anything times your absolute value or divided by on the bottom or plus something. Nothing else by it. Get that stuff away from it. Then we are going to set up two equations without the absolute value symbols. One will equal the positive value, and one will equal the negative value. And then we just solve them, just like our normal equations. So let's look at an example. We have the absolute value of x plus 5 equals 17. So my absolute value symbols, they are isolated. There's nothing else over on this side of the equal sign with them. So I'm going to set up two equations. X plus 5 without those absolute value symbols equals 17, or I'm going to say x plus 5 equals the negative value, negative 17, because this in here could, inside those absolute value symbols, could give us negative 17, and it will be true. So minus 5, so x equals 12, minus 5, or x equals negative 22. One more example. So I'm going to subtract this 3 because before I do anything, because I want this absolute value of 2x minus 4 to be by itself. So get rid of that 3. So it's going to equal 8. So then I say, so 2x minus 4 either equals 8 or 2x minus 4 equals negative 8. And then I solve both of those. Plus 4, 2x equals 12, divided by 2, x equals 6, and then I do the same thing over here. 2x equals negative 4, divide by 2, x equals negative 2. So x equals 6, or x equals negative 2. There are two values that make that equation true.